lesson, we are going to look at integrating factor method for first order linear differential equation. So we will call the integrating factor I of x. So the first order linear differential equation is in this form. So when we find the integrating factor, we find it by this formula. And at the end, we'll be asked to find the general solution of the differential equation. And this is the formula that we use to find the general solution. So let's look at an example of how we can apply all these formulas. So if we solve, you can say solve y prime 1 over x y equals to 2. So we can see that if we relate this with the formula, p of x is actually 1 over x and q of x is actually 2, then the integrating factor is equal to e to the power 1 over x. When we integrate 1 over x, we get that it is ln x. E to the power ln x is actually x. So when we apply the general solution formula, we will have y multiplied by ix. Ix is actually x. Then the integral of qx is actually 2. Ix is x. Then dx here. Let's also have dx there to show that we are integrating. So then now, we don't have to divide by x yet. We can divide at the end. So the integral of 2x is actually x squared plus c. Then we can solve for y. We will find that it is actually equal to x plus c over x. So that is how we use the integrating factor to solve a first order linear differential equation. So let's look at another example. So on the second example, we'll have 2xy equals to x. So the problem can say find general solution. Then the second question can say find particular solution. And particular solution, it is given with conditions. And we call this condition initial condition. So this means that x is actually equal to 0 and y is 2. Then we can start by finding the general solution here. We know that we start by finding the integrating factor, which is e to the power 2x dx. Then it's equal to e to the power, when we integrate 2x, we get that it is x squared. Then that one, we leave it as like that. We cannot bring it down because we do not have a natural log. So now we need to find the general solution. It's going to be I times I of x, which is e to the power x squared, times the integral of, now q of x is x, then times e to the power x squared dx. So now we realize that we need to integrate this, and we can integrate it by this formula here now. Integral f prime e to the power f of x dx, which is equal to e to the power f of x plus c. So this says that the moment we have f of x on top of an exponential, so this time around it is x squared. So the moment we have it like that, we need to differentiate it and see if on the side sits exactly the derivative. So we have 2x, so we can see that that is not 2x, so we cannot properly use the formula. So we need to put that 2x by multiplying by 2, then we divide it outside. And then we can continue now to solve. So we'll have y times e to the power x squared is equal to half. Then we will integrate using this formula, which is simply going to be e to the power x squared plus c. And then we can solve for y. We'll find that it is actually 1 over 2 plus c over e to the power x squared. So that is the general solution of this problem. So now let's find the particular solution. In the particular solution, we know that x is 0 and y is 2. So we need to find the value of that constant in order to find a particular solution. So from this equation here, 1 over 2 plus c over e to the power x squared, we'll put 2 in the place of y. 1 over 2 is there. Then we will put 0 in the place of x. So 0 to the power 2, it's still 0. So we will have e to the power 0 at the bottom. And then we'll have 2, 1 over 2 plus c, because e to the power 0 is 1. Then when we solve for c, we'll get that 2 minus half is 3 over 2. 3 over 2 is actually 1.5 if we want to write it in decimal form. So now we can find a particular solution. So it's going to be 1 over 2 here, plus in the place of c, we'll put 3 over 2 over e. So this is the particular solution. So that's it for this lesson. We wanted to just look at how to find a general solution and particular solution. In the next coming lesson, we will look at how we can apply these first order linear differential equation in word problems. Thank you for watching. Please like this video and subscribe for more content.